Hello, good morning students. Myself Asit Baran Sarkar. My topic is fault in cables. After this lecture, students will be able to learn causes and types of faults. Also methods to locate faults. First I want to discuss about causes. There are 4 causes. First one is dampness of the paper insulation. Second is chemical action of the soil with lead sheath. Third one is mechanical damage. And for last one is high breakdown voltage, etc. Types of faults: ground faults, short circuit faults and open circuit faults. Methods to locate faults. There are 6 methods: Behavior test, Murray test, Worley test, open circuit test, potential fault test. Among these, we will discuss here 6 methods. First one is Behavior test for a single cable faults. Resistance is measured either by insulating far end of the cable or to ground the far end of the cable. Ground fault of the single cable can be located using Behavior test. In this test, low voltage supply, an ammeter and voltmeter are used in a bridge network. Resistance between one end of the cable, sending end, and earth is measured while far end is located from the earth. Location of the fault from the sending end will be proportional to R1 as per following figure. Second method is Murray loop test. To locate ground faults, only valid when cable's lengths are known. Sound cable of the low resistance is used, not to affect the total resistance of the cable. Using Wheatstone bridge principle, fault can be determined and is proportional to the Rx, where Rx is equal to Rb into Rc divided by Ra as per following figure. Third test is very important test, Worley loop test. The only difference between the Murray loop test and the Worley loop test is that Worley loop test provision is made for measurement of total loop resistance. For ground fault and short circuit fault, only valid for the uniform cable sections. And it can be understood with this result. Open circuit test, capacity test to compare the capacity of the fault cable with one which is sound cable. Faulty core and sound cable are charged and discharged with the help of moving coil galvanometer. Deflection is noted, then distance of the break is equal to the A/B into length of the cable. Here A and B are the deflection of the galvanometer for faulty and sound respectively. Next is potential fault test. The fault point distance is given as X equal to L into X, total voltage divided by V1 and V2. L is the length of the cable, V is the total voltage across cable, V1 is the voltage across sound cable, and V2 is the voltage across sound cable. There is a precaution also there. Current should be maintained during test. This method is less accurate than Murray method. This is the disadvantage of this method. In this figure we can calculate the voltage. Thank you.